So we want the constant term. We want the constant term or the independent term. So we are saying for a plus b raised to the power n, the nth term of the binomial, the nth term of the binomial expansion is given by we are talking about the nth term. So it's given by, you can denote with capital U and say r plus 1. So it will be n combination r. We read this as n combination r. Then the first term, n minus r, b to the power r, like this. So this is the formula that we expect you to get. Then you're going to go to your question and identify what your n is. So we'll say here our n is 9, the power. If you compare this and that, your n is 9. Then your a, in that case, your a is x, and your b is negative. Of course, you get with a negative because here you have plus and there you have negative. So you get with a sign that is in front. So you say negative 1 over 2 x squared. That is your b. Then you are going to apply this formula now. So you are going to, let's go to the next page. So you apply the formula. Let's first write the formula, then we plug in. So the formula is a r plus 1, which we sometimes call the r term. Then we have the formula, we said it's n combination r, a to the power n minus r, then b to the power r. This is what we have. Then we substitute now from what we've collected as the data. R plus 1 equals, our n in this case is 9. We don't know the r because we want the constant term. So we want the value of r that will give us an independent term. So we just write r. Then we'll say x to the power 9 minus r. N we know, r we don't know. That's what we are looking for. Then in brackets, negative 1 over 2x squared raised to the power r. So this equation, when you come up with this one, what you do is you're now more concerned of the constant term. So x, first of all, you deal with that. So what we'll do, this r 9 combination r will just be following. Then you have that one, 9 minus r. So here, what you can do is you can separate if you want. You can have two things. You have negative 1 over 2 there raised to the power r, and you can have 1 over x squared raised to the power r. I haven't done anything. I've just separated the negative, that's the negative raised to the power r, so that I can have this around. Then the x, I'll take it in the numerator, so that this becomes 9r raised to the power, this is x to the power 9 minus r. Then I have my negative 1 over 2 raised to the power r. Then I'll take the x in the numerator. So when I take this x in the numerator, the power becomes negative. So this will turn out to be x to the power negative 2, then times r. So it will be 2r because it will be like this, negative 2, then the r outside. Then when the 2 times that, it will give negative 2r, and that's what we have here. Because of the reciprocal 1 over, this power, when you take it in the numerator, becomes negative. Now, these two are like terms, then, so it implies that what we can do is we will put them together. So we have 9 combination r, and this doesn't have x, so we can write it just next to that, 1 over 2 raised to the power r. Then these two, they are multiplying, laws of indices. When you are multiplying two indices of the same base, you add the powers. So it will be x to the power 9 minus r. Then when we add with that, it's going to be minus 2r. Then our interest is now this power, since it's the constant term implies power of x should be equal to 0. So this power of x should be equated to 0. So we are going to get, of course, we can simplify. We know this power, it will be 9 minus 3r. So we are saying this power, we will equate it to 0 so that we can find the value of, so that we can get the value of r. That's the way it is. So we'll get that. So we want to use the other page. We'll just get 9 minus 3r and equate to 0. And so for r, then we are going to have 9, because when we take minus 3r the other side, it will be positive 3r. Then we divide 3. Then this side we divide 3, so that r is 3. So it means the value of r that will give us the constant term is 3. So our interest, so it means when we put 3 there, this will give us 0. So it means it will be x to the power 0. Then any number to the power 0, it's 1. So we'll just remain with this, with the value of r, that then we can find our constant term. So it means our constant term is, we'll just get this because x we have gotten rid of. So our constant term is 9 combination r, then negative half raised to the power r. Then we can substitute what our r is. So it will be 9 combination 3, then negative 1 over 2 to the power 3. Then what do we get 9 combination 3? I don't have a calculator. What is 9 combination 3? 21? No, it's 9 combination 3. It should be 84. Compute for me 9 combination 3. Oh, you don't use calculators. I've just remembered. So, no calculator for you. So what you do is, since there is no calculator, 9 combination 3 for you, it is 9 factorial over 9 minus 3 in brackets, factorial, then 3 factorial. Then times, this guy is going to be negative 1 over 8, like that. Okay. Then from there now, you can deal with this. So that will be, so from there, what we have is 9 factorial. We can write it as 9 times 7, or 9 times 8 times 7 times 6 factorial. Since 9 minus 3 will give us 6 factorial at the bottom, then we have 3 factorial, which is 3 times 2 times 1. Then the 6 factorial can do away. Of course, we have negative 1 over 8, following like that. Then what we can do is, we'll say 3 times this, 3 in here, it will give us 3. 2 in here, it will give us 4. So we'll say 3 times 4, that's 12. 12 times 7, that's 84. So it will be 84 times negative 1 over 8. Then we can have it easier to say this is negative 84 over 8. And we'll say 4 can go in there. 4 can go in here 2 times. Of course, it's negative. 4 in there, it's 1, so 21. 4 in there, it's 2. So 21 over 2, which is approximately negative 10.5. So that's the constant term. Any questions? Any questions? I need to go through again. Okay. So unless there is a question, so we can go to which question again? Which question do we go to? Okay. D. Question.
Yes.
Okay. So question 1D. Use the Cramer's method to solve the linear system of equation. So that is 3x. That is 3x minus 4y equals negative 11. Then we have negative 5x plus y equals 7. So we want the Cramer's rule. So the first thing that we do if we want the Cramer's rule is to come up with a matrix. So we express this in form of a matrix. So it's a matrix of coefficient, of course. So in matrix form, this will be 3, negative 5, negative 4. We're just getting the coefficients. The coefficient of y is 1, positive 1, like that. Then we'll have, of course, the variables is x and y. Then we'll have equals, of course, negative 11 and 7. So this is the way it can be written as in form of a matrix. So now we'll say this is our matrix D. So we'll call this is our matrix D. So we shall find the matrix, the determinant for this. So we'll call determinant for D, the same one. So when you use the straight line, it means it's determinant. Please take note, this is a bracket for matrix or this, but when you use a straight line, automatically you are communicating that you want the determinant. So whenever you are finding the determinant, when you use a straight line, it is determinant. But when you want to communicate that this is a matrix and you use this becomes wrong. So you are going to say 3, negative 5, negative 4, 1, like that. So you're going to find the determinant. Of course, the normal determinant is you multiply diagonal. So this will be 3 times 1, then minus, then you multiply minor, negative 5 times negative 4. So that this is 3 minus negative 20. And that gives us that the determinant is, oh, this is positive 20, negative gives positive. So that gives us negative 17. That will give us negative 17 determinant. Can you switch off the mic with your girlfriend? Okay, good boy. Okay, so the next thing that you do is take note. You have this is the matrix of determinant. So you are going to replace, you are going to find dx. So you replace this x column, this x column with the solution, that is your dx. I know she's there. I know she's there. I can sense. I can sense. Okay. Okay, so let's progress. So we are saying you replace this column. We replace this column with that. So we are going to come up with a matrix. So we'll call dx. We call it dx because we are going to replace the hex column with the b part. So it will be negative 11 and 7. Then this we maintain. It's negative 4 and 1. Then we shall find the determinant of this same part. Same procedure, negative 11 times 1 minus 7 times negative 4. Then this will give us negative 11. This will give us 28. Negative, of course, negative, negative, it will be positive 28. Okay, so this will give us positive 17. So determinant for dx is positive 17. Then get the same matrix. This time we replace the y column. Since it's the dy, we replace the y column with a solution. So it will be our dy will be equal to, we maintain the hex column 3 and negative 5, 3 and negative 5. And this other column we replace with 11 and 17. We replace with the solution part B, 11 and negative 7. Just to confirm if it's 11, negative 7, it's negative 11 and 7. So it's the opposite, negative 11 and 7. So like that, then we'll multiply as per tradition. So it will be 3 times 7 minus negative 5 times negative 11. Then what do we get? We get 21 minus 55. And that gives us 55. That will give us 34, of course, with a negative. So that is our dy. Then we can now find the solutions. So x is equals to dy or dx over d. So our dx is 17. Our d is negative 17. So it means the value of x is negative 1. Then we have our y is, you get dy over determinant for d. So take note, d is always in the denominator. So it will be negative 34 over negative 17. And that gives us positive 2. So therefore, using the Cramer's rule, we found x is negative 1 and y is positive 2. Any question? Is it clear? You can confirm if it's clear. Hello, is it clear? Okay, so we progress to which question? Okay, so which question do we do? Question 2 here. Question 2. Okay, so the question is change the repeating decimal of 3.7 bar to a reduced form, A over B. So we change to reduced form A over B, where B is not supposed to be, using the sum of infinity of a geometric series. So we are using sum of infinity. So we are using sum of infinity to geometric series. So take note, we are using. So what do you do when you have such? Initially, we know this question, when you have 3.7 bar, it just simply means this is 3.7777777. That's what we have. So it means we have the 3 that is not repeating. So what you do is you're going to the right to say this 3.7 bar. Since the 3 is not repeating, you say this is 3 plus, then you put in brackets like that. Then you have the first one, the first 7. So you're going to say 0.7 plus, then you go to the next 7, 0.07. You go to the next 7, 0.007, plus you go to the next one, 0.0007, plus you can go on and on. That is, it's